right, so you do not need a screen in front of you. Can you put your screens down, please? You need a notebook in front of you. We are going to look at about 8 derivative questions, each one about a minute and a half. So hopefully, I don't know, 15 minutes or so of derivatives. And then you will continue on with your Education Perfect practice. So this topic, 6 questions, even better. This topic is called derivatives, tricks and traps. Okay, things to look out for with derivatives. So here is question 1. When you look at question 1, f of x equals 9 divided by x squared minus 15, what does that look like you should do? Quotient rule. Okay, so that's kind of the trap that we don't want you to fall into. What should we do? What's the easier method? Tom? Okay, good. And I heard it from this side of the room too. Put the bottom into brackets, and then it would become 9 times all of the brackets. And then what power do we put on that? Now, what rule should we use? That is going to be a lot faster and easier to do than the quotient rule. Basically, guys, quotient rule, sometimes you will need to do it, but you want to try and avoid it. Sometimes it looks like you should do it, but you don't actually need to do it. So now when I look at that, I'm like, okay, well, f dash x equals, bring the power out the front, -9, keep the brackets the same, drop 1 from the power. We need to be careful with that. -1 minus 1. Good. Then what do I multiply by? 2x, why? Derivative of the inside. Now that power of -2, what is it attached to? Just the brackets, that's it. So we simplify this to -18x, that's -9 times 2x, all divided by x squared minus 15 squared. If you went through and did the quotient rule where you made u equal 9 and v equal x squared minus 15, you would get the exact same answer, but this is a lot less work. So that is probably number 1 of little traps to look out for. It might look like the quotient rule, but in this case, I would recommend not doing it. Now, what makes us able to use the chain rule on this? What are we looking out for? Why didn't I use the quotient rule, and why did I use the chain rule? What allows us to do the chain rule? Yep. That's all right. There is a feature of this function that allows us to do the chain rule. This side. There's what? There's only one thing on the top. Can we be more specific about what that one thing on the top is? It is a constant. So this trick or trap comes out when we have got a constant divided by a function. We can rearrange that to be a constant times the function to the -1. So this one only works when that numerator is a constant. You want to jump in on that, or are you good?
No,
Cool.
I think you guys are so lucky that Mrs. Tucker put this together.
All right. Yeah, sorry?
Great.
Okay, so Ash has just asked a great question. If it is an x on top, let's just put that one over to the side. So if it is f of x equals x over, what was the bottom before? X squared minus 15. What I can see here is I have one function of x divided by another function of x. Okay, so the question is, can I use the chain rule on this? Thoughts? Can I do the chain rule? Okay, let's manipulate it so that we bring g of x up to the top. So let's rearrange it. Sorry, I'm not liking that I've got 2 f of x's here. Let's call this y of x. So let's rearrange it. We've got x times x squared minus 15 to the power of -1. Is everyone okay with how I've gone from blue to pink? I've brought the denominator up to a negative power. Okay, so now my question is, what do you see in pink? Do you see one function inside of another function? Or do you see, like, what do we see in pink happening? Pardon? A product. So you could, instead, if you really don't like the quotient rule, but I wouldn't really recommend this, you could make this a product rule. And you could say, okay, u equals x, v equals x squared minus 15 to the negative 1, u dash equals 1, v dash equals 2x times x squared, put a negative out the front, minus 15 to the negative 2. So you could do it like that, but I probably would just say when we're looking at this function here, it's an actual function of x on the top. It is not a constant, so we can't manipulate that into a chain rule.
And the reason we have the quotient rule is because technically all quotient rules could be turned into product rules. It could happen for every single one. The reason we have the quotient rule is because it's actually easier when it's in that form to follow the u dash v minus v dash u on v squared than to do the product version of it.
Yeah.
So if it is a quotient rule, use the quotient rule. And
So-
that will mean you have the function on top of a function.
Yeah. When you've got actual x's involved in the numerator and denominator, you will need to use your quotient rule. But you can see here, if we went into product rule mode, you can see that this is going to be on the bottom of our fraction. We're going to have x squared minus 15 all squared. What does that resonate with in terms of the quotient rule? V squared, which ends up in our denominator, doesn't it? So you can see, well, that was v on the bottom here, and then we've got v squared. So it will work if you use it as the product rule, but we would prefer when you see two functions of x involved, you have to use the quotient rule or maybe the product rule. So what is the condition of making this a chain rule? It needs to be a constant on the top there. Happy with that? Okay. Number 2, what does this one look like? What's your gut saying? Product rule, that's right. Okay, but what is going to be an easier method? Expand. Yep, expand and then use your what rule? Power rule. So, Miss Kinnear and I would recommend that if you have got probably like 3 terms is probably the maximum I would do, like a 3 by 2 is probably the max I would do. What do you reckon? Yeah, 6 terms. Like a 3 by 2 is probably the most that we would bother expanding by hand. Otherwise, just use the product rule. But for this one, like a 2 by 2, that 2 terms in one expression and 2 terms in the other one, that is going to be a lot easier. Let's just write f of x equals, okay, 11x times 10x is 110x squared minus 165x plus 60x minus 90. Join up our like terms. You guys are probably faster at doing this than I am. That's fine. But I'm going to take it slow so that I don't make a mistake, which I probably still did. Is that right? All good? And now when I look at that, that is so much easier in purple to derive than that original function. Do we all agree? No, you don't. All right, so when I look at that, it is going to be a lot faster to get 2 to 0x minus 105, which is exactly what would happen if you got the product rule. But you know that the product rule can be a little bit finicky. Do you guys know what finicky means? Does that word mean anything to you? Someone give me a synonym for finicky. Troublesome? I like it. Tedious? Good. And that product rule has a little bit of special attention required to make sure we factorize correctly and simplify correctly. All right, laptop should be down, boys. Okay, next one. I'll just get rid of this. Okay. What does this one look like? Quotient rule. Oh, product, I don't think so. Quotient rule. Easier method. So, Ash, this kind of goes towards that point you were talking about before, because this is 2 functions, one divided by another one. But it's a little bit different to the other example that we looked at before was almost the flip of this. And if you have the flip of this, oh no, you could still do the trick that I'm going to tell you. What do we do? Split it.
It's more if your denominator is like 2x plus 1, it's not going to work.
Yeah.
Okay? If it's just
When it
a
can't be
2x
simplified.
or 3x squared, then this can work. It's when you kind of just have like nothing added or
If I've got
subtracted
something
after that.
here, then this is not going to work. Okay, so this one we can divide it. You might prefer to see it split up. So we have y equals 6x cubed over 2x plus 18x cubed over 2x. Thank you. Okay, so let's close up so you're not tempted. All we've done is we've divided the fractions up into two pieces, and then this one is going to simplify to 3x squared plus 9x. Remember, your notation is really, really important for communication. So each step, if we're talking about the original function, we want to see an f of x or a y, and then we can now derive that dy dx equals 6x plus 9. If I've made a mistake, please shout out. Okay, do you agree with me that that method is a lot easier than doing the quotient rule? So when you see, all right, so here we go. We had this one here where there was a constant on top divided by a function of x. Constant divided by a function, we are using the chain rule. When you see functions on top of each other that can be simplified, always look to try and simplify your fraction first, and then you can use your power rule. So really, quotient rule, just always double check. When you see a quotient in your exam, just double check. Can I change this to a chain rule? Is there a constant there? Okay, no. Can I divide this fraction into pieces and simplify? Oh yeah, I can. That's a lot easier, so I'm going to do that method. All right, 3 to go, but they're similar. Okay, what's this one look like? What's it look like? Oh, what do you guys see? Chain rule. Chain rule is used. No, chain rule is when we have one function inside of another function. So we might have like 3x squared plus 2 inside of u to the power of 5. So we've got one function of x inside of another function of x. This is not one function inside of another function. If I put a 5 up here, then it is, but there is no power on brackets. Power on brackets is a good trigger for chain rule. So what else do we see? Thank you. One function, u, times another function, v. So it looks like product rule. Easier method. What's the easier method going to be? Expand. Good. Expand and power rule. All right, go. Go, 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 go. Don't let me beat you. Go, go, go.
All right, you got a 10-second head start. No, not start yet.
Woo, woo.
And now you can begin.
Okay. I'm just going to pause it there for this step. Have we all expanded to that? Okay, now what's easier for us? Powers, what do we do with our powers? Speak up, come on.
There's a constant on top of a function of x. This is another quotient rule 3 times. What are we going to do?
Move them up. How do I move them up? We make them negative powers. We don't need to do a chain rule because it's just x. There is no actual function of x. So I would always recommend if you have x's to powers on the bottom, just bring them up. Now we're ready to derive. I'm ready to derive. So what changes about my working? F dash x, good, crucial. And please, x to -1, -1 from -1, -2. We are not going to do that. We're not going to make silly mistakes like that in our test. -1 from -2 is -3. 92 times 3 is 276. X to the -4. So therefore,
Please don't leave negative powers in your final answer though. So if you've left it with negative powers, make a little note to yourself. You need to put them back into positive indices.
is that what everyone got? Yes? Yeah, I know. People are still writing. Okay, what is actually happening, if we look at this here, I have -52 to the power of 1 times by x to the power of -2. Which one belongs to that negative power? Which one has the negative power? Just the x. That means just the x goes on the bottom and the coefficient stays on the top. It would be yeah. All right, what's it look like? Quotient rule, what are we going to do instead because we're clever? Go. You have 30 seconds. Go. Unit 2 revision tab. Don't like me yelling at you. Too much pressure? You know what you feel like when you're in an exam? You feel like you're under pressure. Try and generate that environment in here. All right, here we go. Y of t equals 6t minus 13. That's a nice one. 13 to the -2. Okay, I'm ready to derive. Y dash of t equals. What's another way I could write y dash of t? dy over dt, good. If you just wrote y dash, why don't I like that? It implies that we're deriving with respect to x, correct. There is no x here, so we are deriving with respect to t. So make sure you tell me what variable you're deriving with respect to. Okay, so we get the derivative, we pull that out the front, times by 6, times by that. 6t minus 13. Take away 1, so I get -1, -12. What? -2 minus 1 is -3? Oh, don't let it trip you up in the exam. I saw it on about 5 of you around the room. All right, hands up if you got that. Okay, last one. Okay, what does this function look like? Complicated. What does it look like though? We've got one function here, u. We've got one function here, v. What's happening to them? Okay, so it looks like product rule, but we can actually do something else. No, there is not one function inside another function. Okay, 10 over 8 to the power of x times by. What is the square root of x to the power of 11 in power form? Tom. 11 over 2. Tom, you're A+ today. Thanks for answering my questions. Okay. X to the power of 11 over 2. So, what? I did too. I don't know. Hilarious. Okay, so we've got times by x to the power of 11 over 2. Now, 10 divided by 8 to the power of x is the same thing as 10 times x to the power of what? Oh, maybe, okay. X to the power of 8. There we go. English, helpful. All right, now I have the same bases here with my x's. So what do I do with their powers? Add them. So 11 over 2 minus 8 is kind of hard. So I'm going to, instead of minus 8, I'm going to make it minus 16 over 2. What does that become?
It's not just 5. What is it?
Negative 5, good, over 2. So that is what my original function is. That is looking a lot easier to derive now. F dash x equals 10 times, bring the power out the front. I'd probably even do that first just for setting out sake, but it doesn't matter. Times 10 times x. Okay, what's the final power going to be? Negative 7 on 2, super. Okay, and now we need to simplify. So I'm going to cross simplify here, 5, 1, negative 25 on the top. This x owns that negative power, so that's the only thing that gets to go on the bottom of the fraction. X to the power of 7 on 2. What does that become? Square root of x to the 7. It's the final answer. Okay, so in a quick summary, you should be looking for chain rules that can be turned into, sorry, reset. Quick summary, look for quotient rules that can be turned into chain rules, or quotient rules that can just be simplified before doing the quotient rule. Look for those two with quotient rules. If we have product rule, double check and see, hey, can I expand this first?
Anything with a power of greater than or equal to 2, don't bother expanding, just use your product rule. So if you have like, if one of those brackets had like squared on it, just use your product rule. You're probably going to save yourself some time. You obviously could expand it, but then you're going to end up with, I mean, so squared is probably the only one I would hesitate to maybe expand. It depends how good you are at that. But certainly if it's a cubic or higher, do not bother.
Yeah, if we've got powers on here, we are not expanding. And then for fractions, look to see if you can expand again instead of doing your product rule. And you've got your power rules there.
It's when you kind of have a function of it.
Okay, guys, hop on to Education Project, please. If you have specific questions, now's a good time to ask Miss Kinnear or myself.